questions 21 through 25 of the 2002 grade 10 AMC 10A. The mean, median, unique mode, and range of a collection of 8 integers are all equal to 8. The largest integer that can be an element of this collection is. So I'll let my integers be A, B, C, D, E, F, G, H. And the first thing is, let's understand this question. Mean, median, mode, and range. So 4 things are all equal to 8. Okay? So let's start with the median. If the median is 8, this is an even number, so that means that these two have to both be 8. That's the only way we can get the median to be 8, because the average of those two numbers is going to be 8. So that takes care of the median. Now let's take a look at the mode. Well, the mode is also 8, but we don't know how many 8s there are. There's obviously at least 2. And therefore, we don't know how many, so the only thing we can do is just list it as 8. But how about the mean? The mean is something that I hope will help us. A plus B plus C, all the way up to G, all the way up to H actually, is equal to, if you take the mean, 8, like that. So the sum of A plus B plus C plus D, like that, will be equal to 64 rather, like that. So we know based on our labeling that D and E are 8, right? This one is 8 and that is 8. So I can take those out and just sort of look at the other letters, the other integers. So if I take out 8 and 8, this sum will be left with is 48. Okay? And at this point, we have to experiment. So the next thing I'm going to look at is the range. Don't forget about the range. Your mean, median, mode obviously are part of it, but the range is also part of it. What do they mean by that, first of all? Range. They mean that if you take the largest number, H, we've listed this from smallest to largest, and the smallest number, H minus A, is equal to 8. That's the range. Okay? So let's now see what we can find. This is all trial and error at this point. So let's move this up. So if we have, let's say, 8 for A. Remember, we can't go higher than 8, because if we go higher than 8 for A, then this is no longer going to be the median. Like if we make A equal to 9, then D and E are no longer the median, right? 9 is now going to mess all this up. So the highest we can go for A is 8. So let's see what we get. If A is 8, H has to be, look up here, has to be 8 more, right? So it has to be 16. So therefore, B plus C plus F plus G has to be 48 minus 8 minus 16, which is 24. So can we get 4 of these equal to 24 and maintain this order up here? And let's see. If you have 4 numbers that add up to 24, each of them, at least one, has to be less than or equal to 6. All right? But that's not going to work because we have our smallest one set as 8. So we can't have another one less than or equal to 6. So that's no good. Okay, no problem. Just keep going. Let's try for this scenario here, up here. Let's try 7 for A, and therefore H would be 8 more than that, which is 15. All right? If we do that, our remaining integers will be equal to 48 minus 7 minus 5, which is 26. How about here? If we have 4 integers add up to 26, at least one is going to be less than or equal to 6.5, but 6.5 is not an integer, so it's got to be 6. So it's the same scenario. We can't have that, right? Because we set our lowest or smallest integer to 7. So that doesn't work. Let's keep going. Let's set a equal to 6. If a is 6, then h will be 14, right? Because it's 8 more. And therefore, the remaining integers have to add up to 48 minus 6 minus 14, which is 28. Now, can this work? If you have 4 integers that add up to 28, then at least one has to be less than or equal to 7. And yeah, that'll work. So now we have to figure out what A, B, C, and D are. A, B, C, D, E, F, G, H, right? So we've got 6 and 14. From up top, remember we had 8 and 8 for D and E. So 8 and 8. And then we want all these guys add up to 28. So how can we do that without messing this up? Well, if we make 2 of these 8s and then 2 of these 6s, that will work. This will be able to all work out. Because remember, we can't go lower than 6 for B and C. And if we made them 7s, then if we made them 7s like that, then these will also be 7s, but that would mess up the entire order. These would no longer be the middle numbers. So the only way to make all the conditions work is with 6, 6, 6, 8, 8, 8, 14. And the largest, therefore, is 14. And that's what they wanted you to figure out, which is choice D. A set of tiles numbered 1 through 100 is modified repeatedly by the following operation. Remove all tiles numbered with a perfect square and renumber the remaining tiles consecutively, starting with 1. How many times must the operation be performed to reduce the number of tiles in the set to 1? All right, so first let's understand this question. Initially, you have 100 tiles, correct? And they are numbered from 1 to 100. All right? And therefore, you've got a scenario where each tile has a number from 1 to 100 on it. And our job in this operation is to remove the tiles that have a number that is a perfect square. And that is what the definition of that operation is. So I will put that over here as the operation number. This is the first time we're doing this operation. And here we go. So initially you have 100, and therefore I'm going to make a table calling this the number of remaining tiles after we do each operation. And here, what are these tiles that are remaining numbered? All right, so here we go. The first time I do this operation, I have to remove perfect squares. So I have to remove 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. These are numbers that are perfect squares. And how many of these are there? Well, there's 10. So I have to remove 10 of these. So once I remove 10 tiles, how many tiles are remaining? Well, initially there were 100, so there will be 90 remaining. Okay? So that is basically how this is going to go. And these 90 tiles are numbered 1 through 90. All right? So that takes care of our first operation, first time we do this operation. Now we do it a second time. Same scenario. We have to remove perfect squares again. So 1, 4, and 9, 16, 25, 36, 49, 64, and 81. We don't have to worry about the 100 because the 100's gone. Why? Because the tiles are only numbered 1 through 90. So we have to remove these 9 tiles. And once these 9 tiles are removed, how many will we have remaining? We will have 81. And those will be numbered 1 through 81, like that. All right, so I hope you get the hang of it. We have to keep doing this here. So let's do it I'll do it one more time. I'll explain it one more time and then I'll write it out because you hopefully will get the hang of it and you can do it on your own. So now I again remove the perfect squares like this, and keeping in mind that these tiles are now labeled 1 through 81. And it looks like I'm going to be able to remove all of them that are from 1 to 81. So again, I'm removing 9 tiles. Okay, so 81, remove 9, we get down to 72. And these are labeled 1 through 72. And you just keep going like that. All right, so I will write it all out, and then we'll see how many times we had to do it, how many operations. So this is the table for the operations. The 4th time I did the operation, I will remove 8. I'll have 64 left, and then so on like that. And eventually you'll get down to 1 tile remaining. And that happens after 18 operations. So I encourage you to just follow the same pattern and you'll be able to get the exact same result. So 22 is 18, and therefore the answer is C. Points A, B, C, D lie on a line in that order, with AB is equal to CD and BC is equal to 12. Point E is not on the line. BE and CE are equal to 10. The perimeter of AED is twice the perimeter of BEC. Find AB. So let's label this diagram. A lot of it is already labeled. AB is equal to CD, so this is the same as that, so I'll just call it Y. BC is 12, E is not on the line. BE and CE, they have already labeled. The perimeter of AED, okay, so we will need to label AE, so we'll call that X, and therefore ED, we'll call that X as well. Right? Because AE and ED must be equal since this diagram is completely symmetric about the center. And in addition, we've got isosceles triangles also, right? So that's why they're equal. So now let's continue with this. We've got this very important piece of information that the perimeters are related in that way. So the perimeter of AED is X plus Y plus 12 plus Y. AED, the big one. And this is twice times the perimeter of BEC, which is 2 times 10 plus 10 plus 12. All right, directly from the diagram. So this becomes 2x plus 2y plus 12 is equal to 64. 10 plus 10 plus 12 is 32 times 2. So this means that 2x plus 2y is equal to 52, and therefore x plus y is equal to 26. Okay, so that's our first piece of information. And now what I'm going to do is I'm going to draw a perpendicular from E down to the bottom like that. Okay? And if I do that, I will cut BC in half. That's the property of an isosceles triangle. So this becomes 6 and that becomes 6. And now we can use the Pythagorean theorem on any of these triangles that I've created a right angle with. So let's just use this one here. They're both the same, right? They're both on each side, they're both exactly the same. So what do we have here? We have this h, which I need to label, squared plus y plus 6 squared is equal to x squared, correct? And this h, we can quickly figure out. You probably can do it in your head, but I'll just do it here using Pythagoras on that little triangle right there. 6 squared plus h squared is equal to 10 squared, and therefore we've got h squared is equal to 100 minus 36. H squared is equal to 64, and therefore h is 8. All right, so we got 8 squared plus y plus 6 squared is equal to x squared, like that. Okay, and then the good news is that we have this formula right here, so we can isolate for one, and that way we can substitute it into the other. So 64 plus y plus 6 squared, and instead of x, I'll put the relationship there. So x in that one becomes 26 minus y, correct? 26 minus y is x, and therefore we have that. So let's solve for this. 64 plus y squared plus 12y plus 36 is equal to 26 squared, which is 676, minus 52y plus y squared. Y squareds cancel. Then we have a whole bunch of numbers here. Bring this 52 over and you get 64y. And you get 676 minus 36 minus 64, like that. This becomes 576, 64y. And therefore 576 divided by 64 is our y value. And therefore y is equal to 9. And y is what they wanted us to figure out, because y represents AB, and that's what they wanted us to figure out. So 23, the number is 9, and the letter choice is D. Tina randomly selects two distinct numbers from the set 1, 2, 3, 4, 5, and Sergio randomly selects a number from the set 1, 2, all the way up to 10. The probability that Sergio's number is larger than the sum of the two numbers chosen by Tina is... All right, Tina chooses two numbers, and Sergio chooses one number. Tina has to choose two distinct numbers, so the first number, she has 5 possible choices. But the second number has to be one of the other 4. She can't select the same one because the two numbers have to be distinct. So for the second number, she's got 4 choices. Sergio only has to select a number, so only one, from the set 1, 2, all the way up to 10. So he's got 10 choices. So the total number of possible selections, I guess, for both of them is 5 times 4 times 10, which is 20 times 10, which is 200. All right? Now, of those 200 possible variations, how many are such that Sergio's number is larger than the sum of the two numbers chosen by Tina? All right, so first let's figure out very quickly, we can do this, Tina's situation here. If she chooses 1 and 2, what is the sum? It'll be 3. Similarly, if she chooses 1 and 3, the sum will be 4. S for sum. 1 and 4, the sum will be 5. And if she chooses 1 and 5, the sum will be 6. All right? So we can make a very quick table here. Similarly, 2, 1, 2, 3, these are her two numbers. And the sums will be 3, 5, 6, and 7. All right? And then 3, 1, 3, 2, 3, 4, and 3, 5. The sums here are 4, 5, 6, and 8. And I think we have just a few more. 4, 1, 4, 2, 4, 3, and 4, 5. The sums here are 5, 6, 7, and 9. And finally, 5, 1, 5, 2, 5, 3, and 5, 4. And the sums here are 6, 7, 8, and 9. Okay? So this is our table. Now, Sergio is going to select a number from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are his selections. What we have to figure out is that for each of these, how many of up there are smaller, because his one number has to be greater than the sum. All right, so let's see. If Sergio's number is 1, can that be greater than any of the sums? No, so 0. 0 possibilities there. If Sergio's number is 2, can that be greater than any of the sums? No, because the lowest sum is 3. So again, 0. If Sergio's number is 3, can that be greater? Right? Remember, larger, not equal, larger. Can it be greater than any of the sums? And the answer is no again, 0. But once we get to 4, the answer is yes. This one. We have 2 possibilities. When Sergio chooses a 4, if, what was her name? Sorry, Tina. I forgot her name. If Tina has a 1 and 2, that will be a sum of 3, and therefore 4 will be greater than 3. If Tina selects 2 and 1, she will have a sum of 3, and 4 is greater than 3. So there's 2 possible ways that can work. And similarly, we got to figure this whole thing out. So 5, let's see, if the sum has to be 4 or less, right? So we've got this one, this one, and this one. So we got 4 of those. 6, the sum has to be 5 or less. So 1, 2, 3, 4, 5, 6, 7, 8. For 7, the sum for Tina has to be 6 or less. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Sorry, this was a 7 in there. And don't make these little mistakes like that. That would cost you the question. All right, no problem. So how many did we underline? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. If Sergio selects an 8, the sum has to be 7 or less. So that looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 9, sum has to be 8 or less, and that's 18. And then sum has to be 9 or less if Sergio selects 10, and that's all of them. All right? So as long as you didn't mess up on the math like I did, then you'll be able to get the right answer. So how many selections are possible? Well, you got to add all these up, right? So you got 2 plus 4 plus 8 plus 12 plus 16 plus 18 plus 20. These are the ones that satisfy our criteria. And the total, remember, was 200. How many total scenarios, total variations? So this is the probability. We just got to do the math now. The numerator is 80. The denominator is 200. And this reduces to 8 over 20, 4 over 10, or 2 over 5. All right? So 2 over 5 is choice A. In trapezoid ABCD, the bases AB and CD are labeled. We have AB is equal to 52 and BC is 12. CD is 39 and DA is 5. The area of ABCD is. Okay. So do you remember how to figure out the area of a trapezoid? If you have a trapezoid like this, and this is A, and this is B, and this is the height, the area of a trapezoid is A plus B divided by 2 multiplied by the height. Okay, so I think we have a lot of the information already. So that's pretty helpful. We just have to figure out, I think, the height, and then we'll be set. So I'll draw two perpendiculars like that, and those perpendiculars, of course, represent the height, h. And I think, well, let's make this a little bit bigger here. Yeah, like that. And then this part here, from here to here, is 39, right? Because it's the exact same as the top. So that means that this part and this part have to be 52 minus 39. So I'll call this part x and this part y. And therefore, x plus y has to equal 52 minus 39, which is 13. Right? So that's the first part. And anything else that they give us? I think that's it. I mean, we've labeled everything else. So this area formula, a plus b over 2 times h, we have a lot of this. A is 39 in our trapezoid. B is 52 all over 2 times h. So if we can figure out h, we'll be able to figure this out. So 39 plus 2 divided by 2 is 45.5 times h. So we'll just use this to figure out h right here. Okay, so now I immediately see, as I'm sure you do, a lot of Pythagorean relationships between those two right triangles. So for the first one, you got x squared plus h squared is equal to 25, correct? And from the second one, this guy here, we've got h squared plus y squared is equal to 144, 12 squared, y squared, sorry. And we know from here that x plus y is 13, so I can substitute that into here instead of having it in terms of y. I can put it in terms of x. So h squared plus 13 minus x, which is what y is, squared is equal to 144, like that. And I think at this point we can just solve this. So in the first one, we get h squared is equal to 25 minus x squared. In the second one, we get h squared is equal to 144 minus 13 minus x squared, like that. And therefore, since these two are the same, we can set them equal to each other, like this. 144 minus, let's solve this out, 169 minus 26x plus x squared, and then this becomes 144 minus 169 plus 26x minus x squared, like that. And then the minus x squareds cancel on both sides, and therefore we can put all the numbers on one side. So 25 minus 144 plus 169, like that. So this becomes 50, 26x, and therefore x is 50 over 26. All right? And I think we're very close to figuring out h. We can use this formula right there. X squared plus h squared is equal to 25. X squared, we know, is 50 over 26 squared, like this. And therefore this becomes approximately 25 minus 3.698. And therefore, if you do the math, you'll get h is equal to approximately 4.615. All right? So we got a lot of numbers here. Let's isolate this guy here. And we can finally solve for the area. 45.5 times h. h is 4.615. And this will be approximately 210. And therefore, the answer will be, for number 25, C.